For decades, the story of desktop computing has been dominated by one name, Microsoft, and one operating system. Windows, from the era of bulky CRT monitors and dial-up internet, to sleek ultrabooks and cloud-connected workstations. Windows defined what mainstream computing looked like, but something has quietly shifted over the last few years. It wasn't a dramatic keynote moment. It wasn't a single product launch. It wasn't even a viral headline. It was a gradual, almost invisible transformation in the foundations of computing itself. And now, in 2026, it feels like Linux has crossed a line that Windows simply cannot follow. This isn't about market share charts alone. Yes, Windows still dominates traditional desktop installations in raw numbers, but the future of operating systems is no longer measured only by how many laptops boot into a familiar logo. The future is measured by flexibility, sovereignty, openness, cloud integration, AI adaptability, edge computing, security architecture, and global collaboration. And in those arenas, Linux isn't just competing anymore. It's defining the rules. To understand why this moment matters, you have to step back and look at how operating systems evolved. Windows was built for an era where the personal computer was the center of digital life. Files lived locally. Software came in boxers or downloadable installers. Updates were occasional. Hardware compatibility was king. Microsoft optimized Windows for that world, and it did so brilliantly for decades. But the center of gravity has shifted. Computing today is distributed. It lives in the cloud, on edge devices, inside containers, across virtual machines, in smartphones, in smart TVs, in cars, in data centers, and increasingly inside AI accelerators. Linux, by design, thrives in distributed environments. It was born in a networked culture. It grew inside universities and server rooms. It became the backbone of the internet. When cloud computing exploded, Linux was already there. When containers transformed software deployment, Linux was the default host. When Kubernetes orchestrated workloads at planetary scale, Linux was the underlying substrate. And when artificial intelligence demanded massive parallel processing across GPU clusters, Linux was the operating system that powered most of it. What changed recently is that the advantages Linux had in servers and infrastructure have started bleeding decisively into the desktop and end-user space. That is the line that has been crossed. For years, critics of Linux would say, it's powerful but fragmented, flexible but inconsistent, secure but inconvenient, innovative but not user-friendly. That narrative is cracking. Modern Linux distributions have matured in ways that feel fundamentally different from the hobbyist era. Desktop environments are polished. Hardware support has improved dramatically. Gaming compatibility has expanded beyond what anyone predicted a decade ago. Creative tools, development environments, and even enterprise productivity workflows now function seamlessly on Linux for millions of users. And because Linux is open source, it adapts faster to new hardware architectures, new security models, and new deployment paradigms than a closed system can. Meanwhile, Windows is facing constraints built into its own legacy. Backward compatibility, once its greatest strength, has become a heavy anchor. Every major redesign must consider decades of enterprise applications, registry dependencies, driver models, and corporate policies. Windows cannot simply shed its past without breaking the very ecosystem that sustains it. Linux, in contrast, evolves modularly. Components can be replaced, rewritten, containerized, or sandboxed without rewriting the entire operating system. That modularity is no longer just a technical detail. It is a strategic advantage. Security is another axis, where the line has become clear. The modern threat landscape is relentless. Ransomware, supply chain attacks, state-sponsored exploits, zero-day vulnerabilities, firmware attacks, AI-driven intrusion methods. The complexity is staggering. Linux's open development model allows vulnerabilities to be audited and patched rapidly by a global community. Its permission model, container isolation, and transparent kernel architecture give administrators granular control. Windows has made enormous strides in security, but it operates within a proprietary framework where visibility and control are ultimately centralized. In an era where governments and enterprises demand digital sovereignty, open systems are increasingly attractive. Then there is AI. Artificial intelligence is no longer an application layer feature. It is becoming embedded into the operating system itself. from on-device inference to distributed model training to edge-based decision systems. AI requires tight integration with hardware and software stacks. Linux's dominance in AI infrastructure means that optimization happens there first. GPU vendors, accelerator manufacturers, and AI framework developers prioritize Linux compatibility. As AI becomes native to operating systems rather than an add-on, the platform that already runs the majority of AI workloads gains a compounding advantage. Consider how developers choose their tools. Developers shape the future of computing because they build the applications, platforms, and services that define digital life. Today, a vast percentage of developers build on Linux or Linux-like environments. Even when they use Windows machines, they often rely on compatibility layers or subsystem integrations that emulate Linux behavior. That tells a deeper story. The development culture has aligned around Linux as the reference environment. When innovation begins on one platform and is later adapted to another, the original platform sets the direction of travel. Cloud computing further amplifies this dynamic. The world's largest cloud providers run overwhelmingly on Linux infrastructure. Containers, serverless functions, orchestration layers, they are optimized for Linux. As more consumer and enterprise software shifts from local installation to cloud-hosted services, the importance of the client operating system diminishes relative to the server backbone. If Linux powers the backbone, it shapes the architecture of the services themselves. Over time, that influence trickles down into user devices. But the real crossing of the line is philosophical. Linux embodies a model of collaboration that aligns with the decentralization of technology. Governments want localized control. Enterprises want transparency. Users want customization and privacy. Developers want freedom to inspect and modify. Linux offers all of that by design. Windows, as a commercial product tied to a single corporation's roadmap and revenue strategy, must prioritize shareholder value, subscription models, telemetry strategies, and ecosystem lock-in. That tension becomes sharper as users grow more aware of digital rights and data ownership. Some will argue that Windows still wins in enterprise integration, legacy software compatibility, and mass consumer familiarity. And that is true in many contexts. But look at the trend lines rather than the snapshot. Educational institutions increasingly introduce students to programming through Linux-based systems. Startups often deploy entirely on Linux stacks from day one. Governments experiment with national Linux distributions to reduce dependency on foreign vendors. Embedded systems, IoT devices, routers, smart appliances, automotive infotainment systems. Linux is everywhere. When the invisible infrastructure of daily life runs on one kernel, the gravitational pull shifts. There is also the matter of cost structure. Licensing models matter in emerging economies and in large-scale deployments. Linux's open licensing allows organizations to deploy at scale without per-device operating system fees. Support can be commercialized, but the core remains accessible. In a world where billions of devices will connect to the internet, cost efficiency combined with flexibility becomes decisive. Another subtle but powerful shift is happening in user expectations. The traditional desktop metaphor, taskbar, start menu, file explorer hierarchy, is no longer sacred. Younger users are comfortable with web-first interfaces, progressive web apps, cloud storage, and cross-device synchronization. Linux distributions have embraced this fluidity. They can look traditional or entirely modern. They can mimic other operating systems, or break away completely. Windows must maintain continuity for its vast installed base. Linux can experiment aggressively because its ecosystem encourages diversity rather than uniformity. Gaming was once considered the final fortress of Windows dominance, but compatibility layers, native ports, and cross-platform engines have dramatically narrowed the gap. Major game distribution platforms support Linux more robustly than ever before. As game developers rely more on cross-platform engines, the dependency on a single desktop operating system weakens. Once entertainment parity is achieved, one of the emotional anchors tying users to Windows begins to loosen. Corporate strategy also plays a role. Microsoft has diversified aggressively into cloud services, AI platforms, and enterprise subscriptions. In some ways, Windows is no longer the center of Microsoft's universe. Azure and AI services are. Ironically, that shift acknowledges the broader reality that the operating system layer is becoming less visible and less central to profit models. Linux's strength lies precisely in being infrastructure rather than product. When the operating system becomes a foundation rather than a commodity sold in boxers, the open model shines. Edge computing illustrates this transformation clearly. Smart factories, autonomous vehicles, remote sensors, and industrial controllers require lightweight, secure, customizable operating systems. Linux variants dominate these environments because they can be stripped down, hardened, and tailored to specific hardware. Windows has offerings in embedded spaces, but the flexibility and licensing structure of Linux give it an advantage in highly specialized deployments. Privacy concerns add another dimension. As users become more conscious of data collection and telemetry practices, open systems offer reassurance through transparency. While not every Linux distribution is perfectly private by default, the ability to inspect code and modify behavior fosters trust. In contrast, proprietary systems must ask users to trust corporate statements and policies. What does all of this mean for the future of operating systems? It suggests that the concept of a monolithic, one-size-fits-all desktop OS may be fading. The future may belong to modular, adaptable, cloud-integrated AI-aware systems that can scale from microcontrollers to supercomputers. Linux already spans that spectrum. It runs on tiny IoT boards and on the world's most powerful supercomputers. It powers smartphones through derivative systems. It anchors container platforms. It underpins vast data centers. Windows, powerful as it is, does not span that entire continuum with the same coherence. Crossing the line means that Linux is no longer merely an alternative. It is a primary reference point for how modern operating systems evolve. When new hardware architectures emerge, Linux support often appears first. When security paradigms shift toward zero-trust models, Linux frameworks integrate rapidly. When AI toolchains update, Linux distributions incorporate them swiftly. The momentum feeds itself. None of this implies that Windows will vanish. Ecosystems rarely disappear overnight. Enterprises move slowly. Consumers rely on familiarity. But influence is shifting. The center of innovation is tilting toward open collaboration. When developers, cloud architects, AI researchers, and infrastructure engineers converge on a common foundation, that foundation gains enduring strength. There is also a cultural component. Linux communities operate globally without a single corporate gatekeeper. Contributions flow from independent developers, universities, startups, and multinational corporations alike. That distributed governance mirrors the decentralized architecture of the internet itself. Windows, even when open to community feedback, ultimately answers to corporate leadership and quarterly earnings. As digital infrastructure becomes geopolitically sensitive, distributed governance can be strategically appealing. Another factor is hardware diversity. The rise of alternative CPU architectures, energy-efficient processors, and custom accelerators favors operating systems that can adapt quickly. Linux's portability and modular kernel design make it easier to optimize for new chips. As computing expands into wearable devices, AR glasses, autonomous drones, and beyond, adaptability becomes more valuable than strict uniformity. In education, the shift is subtle but powerful. Students learning computer science, cybersecurity, data science, and AI often interact with Linux environments from the start. Their mental model of computing forms around command lines, open repositories, containerization, and scripting flexibility. When that generation enters the workforce, their default comfort zone influences enterprise choices. The line that Windows cannot follow is not a specific feature or interface. It is the structural transformation toward openness, modularity, and distributed control. Windows can integrate Linux subsystems. It can embrace open-source projects. It can support cross-platform development. But it cannot fully become Linux without abandoning its commercial identity. That is the paradox. As operating systems fade into the background and services become dominant, the foundation that best supports services at scale wins. Linux has already proven itself at planetary scale. The question is no longer whether Linux can challenge Windows on the desktop. The question is whether the desktop, as traditionally defined, even remains the primary battlefield. In the coming years, we may see operating systems behave more like adaptable platforms than fixed products. Updates will be continuous. AI assistants will integrate deeply at the kernel and driver level. Security will rely on hardware-backed isolation and real-time threat modeling. Devices will seamlessly shift workloads between local processors and cloud clusters. In that environment, the system that was built for openness and distribution from the beginning holds a natural advantage. Linux has crossed the line from being an underdog alternative to being the invisible backbone of modern computing. Windows remains powerful, influential, and deeply entrenched. But the direction of innovation, the architecture of the cloud, the foundation of AI infrastructure, and the philosophy of digital sovereignty increasingly aligned with Linux's design principles. The future of operating systems may not belong to a single brand or a single interface. It may belong to a flexible, collaborative ecosystem that can morph to fit any device, any workload, any region, and any security requirement. And when you step back and look at the global computing landscape in 2026, it becomes clear that Linux has already positioned itself at the center of that future. That is the line that has been crossed, and once crossed, it is very difficult to reverse.